Hello and welcome to our Wednesday webinar from the International Centre for Sustainable Carbon. My name is Rebecca and I'm part of the communications team here. Our monthly webinars are based on our technical reports, which are available from our website www.sustainable-carbon.org. The subject for today's webinar is Carbon Pricing to Support CCUS Deployment, presented by Greg Cook. Over to you, Greg.
Thanks, Rebecca, and welcome to the webinar. As Rebecca mentioned, the topic today for the webinar is carbon pricing to support carbon capture, utilisation and storage deployment. So typically we've always talked about CCS until the last, I'd say, sort of 5 or 6 years, and now CCS tends to be called CCUS. That's the addition of utilisation. So now we're talking about capturing carbon from various sources and not only storing it permanently underground, but also looking at different pathways that may be able to utilize that carbon dioxide, whether through products or different commercial applications. And as we'll see as the presentation progresses, this gives rise to some interesting complications and different pathways which pose some issues for how these technologies can be incentivized through carbon pricing schemes. So just to give you a quick overview of the presentation, I'll begin with some simple context for the study and what the study aims to address. We'll then move on to a fairly brief overview of what carbon pricing and markets are. I'm sure most of you will know the basics, but I think it's useful just to have a quick refresher, and then to consider what the outlook is at the moment for carbon pricing and markets. We'll then move on to a short summary of what we mean by the term CCUS, and crucially, how CCUS technologies can lead to GHG mitigation through different routes. And then a synthesis really of those two parts, asking where does CCUS fit currently into carbon pricing and carbon markets. And then based on that, where we think that there actually could be some interesting new models and concepts emerging around how CCUS deployment could be furthered. And then ending with a few simple conclusions. Okay, so just to sort of kick things off, carbon capture, utilization and storage technologies are increasingly recognized as a key way of addressing climate change impacts and mitigation efforts. So various reasons for that, but if we begin with CCS as sort of the typical, most commonly understood part of CCUS, where you capture CO2 and store it underground, that is clearly a way of allowing a certain amount of continued fossil activity from power generation and industrial sources and so on to continue, whilst also reducing emissions, removing those CO2 streams and keeping them permanently isolated from the atmosphere. In some cases, up to 95% or more of those emissions can be stored underground. So clearly that has an enormous impact in terms of reducing emissions, but also allowing countries to provide energy and economic development. But then more broadly, I think if we think about CCUS, as we'll come on to different pathways and technologies, what they do between them is to allow for a lot of those hard to abate sectors. I'm thinking of iron and steel, cements, refining and some chemicals processes, where there aren't currently or don't appear to be any readily available alternatives, or at least not on a commercial basis. It allows those sectors to continue, but for the emissions to be reduced or in some cases offset through these technologies. So for these reasons, many policymakers and modelling and academic studies have seen that CCUS has a really key role to play in reducing emissions. And crucially, I think if we think about Paris Agreement and the goal of achieving net zero emissions by mid-century, not only CCUS, but also carbon dioxide removals, which as we see is sort of part of the family of CCUS, become increasingly important, because as we reduce emissions over time through normal mitigation, that's reducing emissions at source, we end up with a certain amount of emissions that can't be reduced. And so to achieve net zero, and the clue is in the net part, we have to reduce and remove emissions from the atmosphere to make up for those residual emissions. So incredibly important as, you know, part of the kind of family or suite of technologies for mitigation, CCUS. However, what we see today is that we have extremely low deployment rates. So I'm afraid that the history of CCS policy and incentivization has been extremely underwhelming to date when we look at some of the earliest targets and incentives, going back, for example, to the IEA CCS roadmap almost 20 years ago, and various policy incentives and targets since then. We're finding that very, very few projects have actually gone through and have reached final investment decision, and yeah, trying to achieve bankable projects has been extremely difficult, in short. And as we'll see, there are also some challenges around the utilisation part. So it's not just the CCS, it's also around the CCU aspect as well. So in that context, we're interested in carbon pricing and carbon markets because these are currently the largest or the most significant means of delivering private sector investment into mitigation projects. I don't include the sort of shift towards renewables in that, and that's a slightly different topic. You know, we know that a lot of renewable technologies are able to sort of wash their own faces now in terms of the commercial application, but what we're talking about here are mitigation technologies that are undertaken purely for mitigation purposes, not just to deliver low-cost energy. So incredibly important to look at how carbon pricing and markets can accommodate these important technologies. So therefore, the ICSC study, which I've led over the past few months, aims to do two things. One is to give a current state of play, if you like, for carbon pricing to the extent that it supports CCUS, and then also to provide an outlook on how different carbon market developments at the international level, but also at regional and national level, could help to further support deployment rates. So just to begin with a kind of overview of the role of carbon pricing. So, you know, we know that governments face a variety of policy and regulatory design choices, and they have a whole sort of suite of different levers, if you like, that they can pull in terms of trying to incentivize different mitigation actions. Carbon pricing and carbon markets are only one of those. You know, we're fairly familiar with regulatory policies, sort of command and control regulations and legislation, but carbon pricing and markets have obviously become a fast-growing part of that suite of policy responses, and therefore extremely important, increasingly so over the sort of past 5 to 10 years in particular, around driving low carbon technologies. Important to note that they typically work alongside other policy types. So it's not all about just leaving the markets to incentivize emissions. They can work with other policy types, whether they're quotas, obligation systems, standards, whatever they might be. And increasingly for CCUS, those other policies may be grant-based approaches or fiscal incentives, these kinds of things. But the point with carbon pricing is to try and drive cost-efficient GHG reduction efforts. So that's the main purpose of them, is that you're trying to harness the markets to allow markets and economics to discover where the mitigation can take place most cost efficiently, on the basis that resources are finite, and therefore we want to drive as much mitigation as possible. So what we see now with carbon pricing, and I'm talking here about compliance-based carbon pricing, so this is regulated pricing schemes, is that it's already now covering around a quarter of all global emissions. And then on top of that, what we're seeing with nearly every large or blue chip company now is that they have voluntary pledges, typically around achieving net zero, and these are growing every year. They began in, I would say, in Europe, closely followed by parts of OECD, Asia and America. But what you're seeing actually in most parts of the world now is that most large companies have a climate change pledge, and this is increasingly taking the form of a net zero pledge. What that means is that the role of carbon crediting and offsetting, which is how many of these companies aim to implement their pledges, is going to become more and more important over the next few years. So when we talk about carbon markets, what do we mean in particular? It's around mainly two types of unit, I would say, or value. The first is emissions allowances. So under an emissions trading scheme, as I'm sure most people here will know, you allocate or sell allowances to operators, typically power plants, industrial emitters, and so on. And then these can be traded between them. So you're basically creating a unit of value which can be traded. So hence the market element. The second part of that is crediting programs. So these issue carbon credits to developers of emission reduction projects, and then these can be sold to operators which need to surrender them either against their compliance obligations or maybe within the voluntary market. The point here is that the credits can be used for various purposes. They can be used just for domestic crediting programs, but they can also be used in some emissions trading schemes and in some cases for compliance against carbon taxes. And the figure on the right is just the latest World Bank report on state and trends of the carbon market. This is 2024 version. And what it's showing you is the coverage of different compliance-based carbon pricing instruments worldwide. So what you're seeing in the red areas is where we have compliance systems. So these are emission trading schemes and carbon taxes. The blue one is showing you where you just have a crediting system. So this is where you can develop domestic credits for compliance, but they don't factor into an ETS or a carbon tax. And then in the grey areas, we have both. So just to take a couple at random, we can see that the EU and the UK, and in fact Norway as well, are covered by compliance schemes. Some of them, including Spain, Portugal, and the UK, have both. In the US, we're mainly talking about a patchwork of different states that have crediting and compliance schemes. Mexico has a tax system and an ETS, but it doesn't have a crediting scheme, and so on. So it's a bit of a patchwork, but the important point is that most developed countries and an increasing amount of developing countries do have compliance schemes for carbon pricing. And they can include emission trading schemes, carbon taxes, and also crediting systems. So just on this last point around the use of crediting, so I mentioned that they can be used within ETS and carbon taxes for compliance. So this is important because it means that credits can be used to develop mitigation projects, which then have a ready-made demand and market for them to be used. But important to note here that it depends on the ETS, and most emission trading schemes have made use of carbon credits, but in very different ways. So just to give you a quick flavour, this is another snapshot from the World Bank report, and what it shows is that some ETSs you can actually surrender up to 100% of your compliance through using carbon credits. For example, in the Australia, Indonesia, and some of the Japanese schemes, and the carbon taxes in Chile and Mexico. Whereas actually for most other ETSs, there's a much smaller use of credits. And this is because most ETSs want to incentivize emission reductions in those actual covered facilities. So that's the whole point of most ETSs, is that you are trying to maybe move away from fossil fuel use, or to introduce more low carbon technology in industry. And therefore, you don't really want to be relying on a huge amount of carbon credits that may be coming from forestry or renewable energy or other types of projects. So it's about keeping the emission reduction incentive within the installations themselves. And this is important because actually the largest ETSs, such as Chinese and the Korean and the EU ETS, for example, don't include large amount of offsets. And in fact, the ETS doesn't include any offsets now. Whereas Chinese and the Korean ETS do include offsets, but a very small amount. So just a bit of a bit more of a deep dive into some of those schemes. So emission trading schemes, as we've seen, vary wide in terms of number of factors. You know, some include sectoral coverage across quite a wide range of different sources. Prices, others may be much more narrow. The prices of carbon within the schemes can vary considerably, from as little as around $1 a tonne to over $100 a tonne in some European schemes. The allocation can approach, crucially, there are variations in which technologies are recognised within them, and also the type of cap and the stringency of the cap can vary considerably also. So they can be country to country. So actually this is what the Kyoto Protocol involved, was country to country trading of emissions rights effectively. They can also be regional. So we think about the EU ETS as the clear case on the regional trading, but there are other cases in North America too. And of course they can be national as well. So you know, we think about the Korean ETS, the UK ETS, Chinese ETS, and so on. And they can also be state level or province level. Perhaps the most well-known of the state level ones would be the California emission trading schemes. As I mentioned, they can integrate carbon credits to meet compliance obligations. So the rules around these vary in terms of how much carbon credits can be used in terms of the overall percentage level, but also what types of projects can be permitted, and also whether projects need to be within the country itself or can be international. And the last point here is that what we're seeing over the last few years is actually a really strong growth in countries signing up to developing their own emissions trading schemes. And increasingly, as they do that, there's going to be more efforts to link those schemes. That's already happened in parts of North America and obviously in Europe, but already in places like in the ASEAN, for example, there are efforts to try and look at how schemes could be linked over future years. And the point with linkage is that you would harness more cost-effective potential because you're widening the market, so therefore putting buyers and sellers into closer contact with each other within an expanding base. So that's ETS, and then the other sort of main part of the jigsaw here is carbon crediting mechanisms and market segments. So this is just an attempt to try and simplify the use of carbon crediting in carbon pricing and carbon markets worldwide. And I think it's useful to break it up into kind of supply and demand effectively. So when we talk about the sources of carbon crediting, there are three main sources. First is on the international side, so it's international crediting mechanisms. So this used to be, the main one used to be the CDM, and I think most people will know the Clean Development Mechanism under the Kyoto Protocol, but with the Paris Agreement, what we're now focusing on is Article 6. So you may have heard lots of talk about Article 6. There's different parts of Article 6, but for the purposes of crediting, it's Article 6.4, which we're most interested in. And this is now, since Baku in the COP last year, has become known as the Paris Agreement crediting mechanism. But effectively, although it's a simplification, you could think of it as a successor to the CDM. So this is where project-based credits can be generated and used for compliance in other countries. So that's international crediting mechanisms. We then have government mechanisms. So these are mainly nation states developing, sometimes subnational states, such as the California example here, developing their own regulated mechanisms for generating offsets. So they have their own standards, their own rules around what projects are eligible and so on. And then last but not least, we have what are called independent crediting mechanisms or independent crediting programs. So these are typically, but not always, used for voluntary purposes. And there's a whole range of these. I mean, there seems to be a new crediting mechanism and standards every few months being announced in the press, but the two largest ones that you probably would have heard of are the VCS. So this is the standard by Vera, and also the gold standard. And these standards have a whole range of different methodologies, rules, protocols that have been developed, covering, I mean, in the case of BCS and gold standard, almost any mitigation technology you could think of, really. So very long lists of methodologies that can be applied. So then on the demand side, we have international compliance markets. So these are countries that can purchase credits to try and achieve, to offset their own NDCs, their targets under the Paris Agreement, but also for other international compliance purposes as well. And the most important of those is the airline industry's CORSIA agreement. Then we have domestic compliance markets. So I mentioned the ETS and the carbon taxes that are emerging worldwide. So this is what I mean by domestic compliance markets. But also some countries have domestic crediting systems as well, which may be baseline and crediting. So baseline and crediting schemes, domestic crediting programs, carbon taxes, and emission trading schemes are all important source of domestic compliance markets. We don't really need to get into the results-based finance, but just to mention that some of these crediting mechanisms can also be used as a way of verifying results-based finance. This is finance typically coming from government donors or the World Bank and other donor parties. A lot of that money has typically gone into forestry and other land use projects, but can also go into energy and industry related projects too. And then finally, the largest source of demand for crediting is the voluntary carbon market. So this is where corporations are developing their net zero targets and pledges and are therefore seeking to acquire carbon credits and offsets to try and achieve those in addition to their own reduction efforts within the companies themselves. So as you can imagine, if you were to tie up all the different sort of connections between the carbon crediting supply and demand, and then also how they interact with the ETS and carbon taxes across the international, regional, national and state level sectors, you'd end up with quite a complex ecosystem. And that's what we call the carbon market. I just wanted to touch or move us into the discussion of the CCUS by thinking about how the carbon market can incentivize different types of mitigation efforts. And the way that the conversation at the moment and a lot of the literature is considering the use of offsetting is around a distinction between emission reductions and carbon removals to begin with. So just briefly there, emission reductions, we mean there is to reduce GHG emissions at source. So very simply, it could be swapping from fossil fuel power to renewable power, or indeed capturing and storing that fossil power. But that's emission reduction. So that may be avoided emissions, or it may be literally reducing emissions. Against the other distinction, which is to remove carbon. So removal of carbon is basically removing carbon dioxide from the atmosphere where it's otherwise be in the atmosphere, causing climate change effectively. But there are different ways that that can be removed and stored. So then the second layer here is the carbon stored? No or yes. And then how is it stored? So different ways of storing carbon, as you know, it can be stored geologically, it can be stored in products, which will come on to through the CCU pathways, utilisation pathways. But importantly, this gives us a whole kind of continuum, if you like, of where the emissions are stored. Is it avoided? Is it stored? Is it both avoided and stored? And how long-lived or short-lived is that storage? So as you can imagine, within carbon markets, these are really incredibly important questions because they determine buyer preferences around what people think they're getting in terms of the efficacy or the quality and integrity, if you like, of the removals. So just to pick up on a few of the kind of topics, if you like, or discussion areas within this space in the market. There's a big debate going on at the moment. In fact, it's been going on for a long time around the additionality of many emission reduction projects. So additionality is whether these would have occurred anyway. And a real close focus on a lot of renewable energy projects, for example. And so for this reason, some carbon credits that are originating from renewable energy actually have very low price in the market because they're not seen as being particularly credible. Obviously, you could do a whole separate presentation just on that topic alone, but that's just all I wanted to say on that one. Many buyers are avoiding projects that are seen to prolong or even be connected in any way with fossil fuel use. So this includes CCS projects as they may pertain to fossil fuel plants and industrial facilities, particularly where they may involve enhanced oil recovery. So there's some buyer preferences around CCS, which is suppressing the demand for these kind of credits also. And then finally, what we're seeing is that there's a focus on carbon dioxide removals as actually now, in some views, as the only credible offsets that can be used to neutralize ongoing emissions within companies. So this is most commonly a discussion that's taking place within the voluntary carbon market. So what we're talking about here is where companies claim that they can't reduce their own emissions for various reasons. They have hard to abate residual emissions. They're looking to offset those emissions through other means. There's a strong preference at the moment, particularly within tech companies such as Microsoft, Google and so on, to buy carbon removal projects, but in particular engineered carbon dioxide removal projects, which we'll come on to, where you have removals and storage, creating so-called negative emissions. And these kind of credits are commanding much higher prices than the other types of credits. So before we move on to a bit of a discussion around what we mean by CCUS, I just wanted to end with a bit of an outlook quickly on carbon pricing. So this gives us a flavour for why it's so important to be looking at pricing and carbon markets. So ETSs are currently the largest carbon markets worldwide, and I think we're already over $1 trillion US dollars globally in terms of the overall value of those emissions allowances. Yeah, as I mentioned, we're seeing new emission trading schemes being announced by countries almost on an annual basis. But importantly, more than 90% of demand for carbon credits is actually coming from the voluntary carbon market, the VCM. Apologies for all these acronyms, I couldn't get around it. And also keep the slides fairly short. So VCM carbon market, voluntary carbon market. So that's actually where most of the demand's coming from carbon credits, not from emissions trading schemes, because as we've seen, most of them only allow a small amount of carbon credits, and many operators choose not to use those credits, but to actually just surrender allowances. Within the voluntary carbon market, there are concerns around integrity. I mentioned renewables and how additional some of those projects are, but all sorts of other issues, particularly around forestry. This is leading to a whole range of different legislation emerging. So we have the EU Corporate Sustainability Reporting Directive, trying to ensure that companies aren't claiming things they shouldn't be. In the US, we have the SEC rules being developed and so on. Another really important one, actually, just to mention in passing, is that the EU's carbon border adjustment mechanism, which may also be announced by other countries, maybe not in the US now with Trump in power, but in certain other countries, such as Australia and Canada. So you're probably aware, border carbon adjustments are an attempt to try and impose equal carbon prices on imports to those countries that have ETSs. This is actually really driving a lot of this discussion, particularly in Asia and South America, around developing domestic carbon pricing so that they don't have to pay these border adjustments. So yeah, that's driving things forward as well. We now have some agreements around Article 6 rules and the Paris Agreement crediting mechanism, although that's really probably going to take another year or two to shake out. But there's agreement reached there in principle. And so just putting this all together, what we can say is, in a very pithy summary way, is there are all sorts of uncertainties around the outlook, but nearly all studies, market and academic alike, indicate very strong upward growth for carbon pricing and markets over the coming years. So this little figure on the right is just a snapshot on looking at the voluntary demand for carbon credits under different surveys and scenarios. Need to go into numbers, but what you can see is that where we are at the moment compared to where most expectations are over coming decades is clearly quite a big step change. So voluntary markets expected to grow very significantly as corporates look for more and more credits, and also countries introduce their ETSs and carbon taxes, some of which will use those credits also. Okay, so that's the markets and pricing bit out of the way. This is an attempt, I mean, I think this is quite a nice figure actually, it's not mine, this is from a paper by Lou and others, just to map out all the different, kind of pathways that CCUS, what do we mean by CCUS? And I think this just sums it up. There are lots of different possibilities and pathways around the capture side. So we begin with the capture, it can come from fossil fuel plants, industrial emissions. Next is bioenergy with CCS. So this is burning bioenergy, which has removed that CO2, typically in power plants, which can then be stored. That is direct air capture, which I'm sure you've heard of, increasing attention over recent years, remains very expensive, but basically it's sucking CO2 out of the air, which can then be stored. We then have different ways that CO2 can be transported and delivered, whether to a CO2 utilization route on the left-hand side here, which can be for EOR, enhanced oil recovery, for example, chemical utilization or biological utilization, or whether it can be stored typically underground in geological formations, both onshore and offshore. So briefly, just on the CCU part of the pathway on the left-hand side, we're mainly interested here in commercial applications of carbon dioxide. So we're talking about the use of CO2 in chemicals and different products. These can be aggregates. CO2 can be used as drop-in fuels and additives, and also can be used as a solvent or working fluid. So on the left-hand side there, you can see CO2 EOR. So this is where you're using the CO2 as a way of enhancing oil recovery, some of which may be stored permanently, which makes more and more complications for determining the abatement effect. So just to overlay on this, what we talk about engineered CDR methods, these can result in so-called negative emissions, which is the reason that they're attracting so much attention from policymakers and buyers, credit buyers. So the important point here is that they can, because they result in negative emissions, so-called, because they're storing and removing at the same time, they have an incredibly important role to play in helping to achieve the Paris Agreement goal of balancing emissions and removals by 2050, which is the net zero target. So in summary, we have a whole umbrella of different technology pathways and applications. So what that means for mitigation is that we have a fairly messy and complex picture in trying to determine what those mitigation or abatement effects will be. And this is just one picture, and this is just for the utilization pathway, not for the CCS part. This is some work I was involved with about 10 years ago for the Commission, and it was an attempt to try and map the different CCU categories, the different technologies within them, and the abatement effects. There isn't time to go into all this in much detail, but just to mention that we have a whole range of different abatement effects depending on those technologies and applications. Sometimes they may be even mixed up within the particular technology application. So, with CO2 to fuels, you're typically displacing fossil fuel-based fuels, but there may be liquid fuels in transport. But also some may or may not involve different temporary or storage, temporary or permanent storage. So typically you're burning the fuel and the CO2 is re-released. Enhanced hydrocarbon production like CO2 ER. You can have a certain amount of permanent storage, but then there are some very complex questions around whether you have so-called leakage. That's not physical leakage here. It means whether the EOR, for example, is creating additional markets for the oil and the oil products that wouldn't exist otherwise. Mineralization pathways typically lead to permanent storage, but there's some complexities around that. And most complex of all is where you're using CO2 in chemicals. You get a whole range of potential abatement effects and storage effects depending on a whole range of things. I mean, you know, which chemicals you're displacing and the chemistry itself in the pathway. So this picture is further complicated by the fact that some of these CCU applications may be requiring fairly large energy inputs. And of course, those energy inputs may or may not be from fossil or renewable sources or a mixture of the two. So fair to say that it's a fairly mixed and complicated picture just on the technical level. We'll come back to that when we try and make a link with the pricing, but I wanted to end just with a bit of a snapshot on what some of the studies are saying around the deployment potential. It's fair to say that there's very high deployment potential. So this table is showing you the IEA's net zero emission scenario and showing you the it's not an expected outcome. It's a kind of best case, I guess, or what the IEA think should be happening on a cost-effective basis for us to achieve net zero globally. And this is the contribution coming from carbon capture across a different range of sources. So we're currently at around, this was 45, but we're now about 51, 52, I think, of million tons per year of CO2 captured. But you can see how that needs to increase over the coming decades and the kinds of sources for the capture. So a lot of it coming from fossil fuel industrial process, in fact, most of it, in particular industry. And we're talking there about typical large-scale heavy industry, iron and steel, refining and so on. We then have capture from bioenergy. So this includes some of that so-called BECCS, which can lead to negative emissions, but other routes also. And then finally, direct air capture at the bottom. And yeah, just one outlook or study from Boston Consulting Group, looking at the kind of markets which they think are most useful or promising rather for carbon capture and utilization. And there are lots of different ones here. This one seems to have a very sanguine, upbeat outlook for construction aggregates and cured concrete, less so for some of the fuels, but I've seen others which have more of a focus on the fuels. But they all agree that the market potential is extremely large, even though there are some big commercial and technical challenges to overcome. So lots and lots of agreement around the deployment outlook and the potential, if you like, the market potential. However, what we see at the moment is very, very low deployment rates compared to where we think things should be, or people are saying that they should be. As I mentioned, there's been a sort of very sad history, really, of CCS project cancellations. You know, a lot of it has been grants that have dried up, that haven't then sustained the projects. They haven't moved to bankable status. Issues around social acceptance, the kind of NIMBY, not in my backyard type issues, I guess. And some of the funding programs have sort of come and gone with different changes of government and the electoral cycles. So although there's a fairly promising pipeline at the moment, when we look at some of the good work that the Global CCS Institute has done, for example, tracking projects, we can see that obviously there's a need for some very strong policy support to not repeat some of the past failures. So considering CCS in carbon pricing, we can see that there are some issues that are specific to CCUS. I think a lot of these stem from the need to reward CCU technologies. They need to be MR viable, and I think this is the crunch issue here. So you need to recognize the emission reductions or avoided, because the ton has to be a ton for it to work within the market and have a value. This can be extremely important because the abatement effect can occur between different parts of that CCUS chain. If you remember that kind of ecosystem of different routes there, it's extremely hard to track that across the chain. And then also accounting for the effects. And as I mentioned, we have a whole range of different technical complexities that mean that accounting for the abatement effect is typically quite difficult and doesn't fit into more traditional accounting approaches. Also, some pathways have reductions and removals, and actually separating them can be quite complex. And that's a problem because, as we mentioned earlier, some buyers only want to be looking at removals and not so interested in the reduction part. And then finally, there's a whole range of sort of non-technical, if you like, methodological issues around acceptance, managing some risks and liability in the event of any CO2 reversals or leaks. And as we'll come on to, also aligning cross-party interests across all those different parts of a CCS project chain. So just to now sort of move into actually looking at the evidence and the review that we did as part of the work. What we've looked at here are some of the most important ETSs. It's not exhaustive, but these are the key ones globally, and then looking at how they apply to CCUS, and we've broken it up into CCS. So this is the typical, if you like, more sort of traditional carbon capture and geological storage projects. Then carbon capture and utilisation. There's an overlap between the two because you can have storage and utilisation in some cases, but just keeping it simple and separating it out here. And then finally looking at the engineered carbon dioxide removal projects. So these are the BECCS and DACS projects. So where you have bioenergy captured and permanently stored, or direct air capture and permanent storage, the so-called negative emission projects. So on the CCS side, we can see that there's actual inclusion of CCS or attribution in ETS within the EU ETS. The first one was actually Norway, a Norway ETS, which has incentivized Sleipner and Snøhvit projects. The UK ETS also acknowledges CCS. The way this is done, by the way, is to recognize permanently captured and stored emissions as being removed from companies' GHG inventories, and therefore they don't need to surrender allowance. So that's the way that it's accommodated within the ETS. And also the Canadian federal ETS system and several of the provinces within the Canada system. So on the CCS front, you can see, unfortunately, that many other the ETSs do not currently include or incentivize CCS. So we move on to carbon capture and utilisation. The key ones here actually are New Zealand, where CCU is included as being embedded. So anything which is embedding CO2 is recognised within the New Zealand ETS. And also the EU ETS, which now has a derogated act, I think it's called, isn't it? A derogated act, which is sort of appended to the ETS regulation. And this is for chemically bound stored CO2. And the UK and the Norway ETS also implicitly recognise EOR within CCS activities, which is obviously a CCU technology. And then on the CDR front, it's really the EU and the UK, which are the only two ETS schemes which are now currently looking into how BECCS and DACS can be accommodated. So that's underway at the moment. Because both schemes have signalled that they want to include negative emission technologies within the ETSs. So that's being developed, hopefully with results later this year or 2026 in the case of the ETS. So what we can see is it's fairly patchy in terms of the ETS inclusion for those technologies. Very briefly on the domestic crediting side, it's really the Alberta emission offset program, which has incentivized the Shell Quest project, for example, which is a very large CCS project, which has been underway for nearly 10 years with 12 million credits issued to date. And also the Australian scheme more recently, this is the Moomba carbon capture and storage project, capturing from a large gas plant, which aims to store up to 2 million tonnes a year. But these are really the only two schemes with any sort of major accommodation for CCUS projects. Moving on to the voluntary carbon market and crediting schemes. What we have to date on the CCS front is ACR, which was one of the first methodologies and programs to include CCS, but undertaken for EOR purposes, where most of those projects have been talked about, but nothing actually developed to date. Vera also has its own CCS, it's called the CCS Plus initiative, which is a kind of modular, very large methodology approach, which covers BECCS, DACS, CCS from other sources, including fossil. And that's underway at the moment, no projects registered to date. And also the Global Carbon Council project, again, no projects. So we have the methodologies in place, if you like, and being developed, but no projects to date. It's actually a bit more progress on the utilisation front, funnily enough, because Vera and Gold Standard now have some projects registered. So Vera has two methodologies, one for storing CO2 in plastic materials and one in concrete production. And I think there's 8 or 9 projects at different stages of development there. The Gold Standard has a BECCS standard and also a carbonation of concrete aggregate methodology. And then finally, you can see that these are some standards that are emerging and initiatives that are focused purely on carbon dioxide removals, most notably Puro Earth and isometric. So these are developing methodologies, or that have been developed now, mainly for BECCS and DACS projects. And this is where a lot of the focus is on the VCM at the moment, particularly from the tech companies, which have very deep pockets and aim to be offsetting all their emissions through removals. So yeah, most notably Puro, isometric, but we also have other initiatives such as CarbFix and Stockholm Exergy. I'll move through this very quickly in short of time, in view of time, but I just wanted to mention that CCUS gives rise to a whole range of particular risk issues which have to be addressed through safeguards. And this creates a real issue, I think, for developing carbon crediting programs, because they need to be addressed within those methodologies in some way. The way that they've been done to date is typically to limit the geographical restrictions of those methodologies. For example, the ACR is focused on North America, where they know that there's safeguards in place through regulation of CCS activities, in particular storing CO2 underground. The problem is that we look around the world, we don't have those in place for other countries, so this is acting as an impediment for developing CCUS projects in other parts of the world. So there's a whole range of initiatives around trying to close that gap, if you like, and I just draw your attention to one which is being developed or has been developed and is being updated by IETA in partnership with Mitsui, and this is the high-level criteria for carbon geostorage activities. So that's an attempt to try and introduce safeguards to carbon crediting programs where we're talking about CO2 storage and addressing the risks that can be associated with release of the CO2. So that's hopefully a snapshot of the complexity involved, not only in the pathways, but in how they are applied to CCUS is applied to carbon pricing and markets worldwide. Just wanted to finish the presentation with a final section, which is looking at emerging markets and new models. So what we can say is that there's a whole range of uncertainty around actually whether existing approaches to carbon pricing can actually deliver CCUS at scale. And I think you've probably got a flavour of some of the reasons why these difficult projects and complex projects are not always readily suited to existing approaches such as emission trading schemes and traditional carbon crediting for a whole range of reasons. We can see, in addition to some of those accounting and abatement quantification effects, that there's a so-called agency problem, and this is really quite specific to CCUS projects. So unlike renewables or forestry projects, we tend to have very large chains. If we think about beginning from the capture facility, CO2 leaves the gate, it may be transported many kilometers via pipeline or LNG even, through shipping, not LNG, sorry, but through shipping. That CO2 is then stored or utilized or both. We're talking about a whole different range of parties. They may even be in different jurisdictions that then need to align their interests through different contractual arrangements and so on. And the problem is that you have the agency problem, because it could be that the company or the operator involved on the capture side has no agency, has no ability to actually act across the entire chain for the purposes or for the benefit of the project as a whole. So, for example, under most emission trading schemes, you're putting the incentive on the capture plant to reduce its emissions, and the storage operator, that might be the oil and gas field operator, for example, doesn't have any particular interest in storing and monetizing that CO2. It may introduce a gate fee for the CO2 to take the CO2 off, which may be prohibitively expensive to incentivize the upstream actors, if you like, to undertake the capture plant. And that's only one of them. There's a whole range of issues and challenges that arise from this chain, cross-party chain risk, it's usually termed. What this means is that there could be some problems with all these traditional forms of carbon pricing models, which is leading many policymakers and commentators to talk about some new models and explore some new models. One of the ways that have been talked about is linking ETSs so that you can bring those parts of the chain together. There are some problems here, though. Some recent analysis by ITER and University of Maryland shows that as you link up ETSs, this may not be particularly good for CCUS because the focus will probably be on the least cost options, if you like, a kind of race to the bottom, which might bring in a lot of fairly suspect, I would say, forestry projects and renewable projects, and also actually just the political and methodological challenges of linking emission trading schemes are quite difficult. Again, another subject, another podcast, webinar. But what we can do is say that there are alternative policy proposals that are trying to cut through some of these issues, and most of them are based on what's called supply side offsetting with storage crediting, including the use of so-called CCS clubs and trading of carbon storage units. So what we're talking about here are mainly oil and gas, the idea that oil and gas companies could cooperate on reducing their emissions in line with their net zero targets by offsetting their residual emissions in the embedded products that they produce, oil and gas, through using storage quotas. So what that means effectively is that you have a quota to store an equivalent amount of carbon for the carbon that's embedded in your product. This allows the oil and gas companies to continue producing over coming decades, but to offset the emissions through storing the CO2 in geological storage media. A whole range of reasons why this is being talked of as being interest. These tend to be the same companies and corporations that are able to have the knowledge and the expertise to store the carbon, but also it allows them to continue delivering their products, for these to be part of the low carbon net zero strategy. So this is just to give you a quick snapshot of some of the analysis that's been undertaken. Here, for example, we can see model 1 linked to carbon markets, determined not to be effective, and the graph here is showing you two other models. The first one, model 2, is where you have voluntary pledges from oil and gas companies with the use of trading. And model 3 is where you have country pledges. So this is now bringing in not only oil and gas companies, but national energy companies in developing countries, which are taking on storage targets under their NDCs, their national developing contributions. This is what we call CCS clubs, for example. So where countries get together and they decide to cooperate on achieving these targets. And this particular study found that top-down country-led approach, model 3, was found to be particularly effective in driving CO2 storage. So the graph is showing you there on model 3, the carbon embodied in the oil and gas products in million tons of CO2. So beginning at around, I think, 12, 13 gigatons. That's coming down over time as these countries collectively move towards their net zero targets. But the CSU demands, so these are the units, the carbon storage units, increasingly the demand is coming up as you achieve net zero, and of course then they line up at 2050. So this is where there is a net zero, because any remaining emissions that are used in the oil and gas embedded in those products are 100% offset by the equivalent amount of CSUs. So they're offset by the equivalent amount of CO2 which is stored in geological storage sites. So Model 3 is larger because you have here all the major oil and gas companies that might act within a CCS club. Model 2 is still of interest, but here we're talking about large multinational oil and gas companies. These are the Shells, for example, and the Oxys and BPs and so on. The challenge here is that despite there being some signs of interest, there are no sort of firm targets or policy proposals that are being announced here. But there's a lot of interest here because it could potentially overcome some of those issues that we've seen with existing, more traditional, if you like, carbon pricing forms. And the way that this would happen would be through the Paris Agreement, Article 6. I haven't really had time to go into the details of that. But basically, Article 6 allows countries to cooperate together and companies to cooperate together, often in partnership with countries acting as parties to the Paris Agreement. So just to round this out then with some conclusions and takeaways, we've seen how there's general agreement that we need widespread deployment of CCUS to try and achieve net zero. As carbon markets are growing, we know that carbon pricing is going to play a more important role over coming decades to try and leverage private investment. So putting those two things together, unfortunately, CCUS presents some very specific considerations and challenges that need to be addressed if they're to be included within traditional forms of carbon pricing, such as ETS, carbon taxes, and carbon crediting schemes. What we can see from the review of existing schemes and their take-up is that there's very patchy inclusion of CCUS. I think there's some promising areas, particularly around the voluntary carbon market, but issues around the accounting and other considerations are meaning that they're not being taken up to the extent that I think they could be and need to be to try and achieve those target levels of deployment. And finally, we can see that the crediting of some of those activities poses some really quite significant challenges due to some of the risks, in particular of non-permanence, which need to be addressed through safeguards. And so some of the initiatives like the IETA criteria are very welcome, and hopefully we'll be able to extend some of those crediting schemes to other parts of the world outside of Europe and North America over the next few years. But finally, I think, when we look back and we see that there's been some real significant failures around CCS deployment in particular, if we're to avoid another round of failure over the next decades, I think it's quite clear that we may need to be moving into some new areas of thinking. And just that quick snapshot that I showed you around the idea of having CCS clubs and carbon storage offsetting is just one, and there are others. So I think that's really crucial to think about, not only existing forms of carbon pricing, but some new emerging areas, particularly with agreement now reached on Article 6 of the Paris Agreement. And with that, I will end there, and I know that I've probably taken up much of the time, but I will thank you for your attention and move over to any questions that you may have. So I don't currently see any questions, but I believe that there's still time to register any or put any in the question panel there. I should say that I'm very happy to receive questions and follow-up clarifications after the webinar. And you'll see my email address at the bottom there. I see there is one question from Ian. Yeah, I see that there's a question, but I don't see any content to it just yet. Okay, so the question from me and Reed is, the change in administration in the USA is likely to impact CCS. How do you see it? So, okay, so at the federal level, clearly it's a major setback in terms of looking at incentives and the overall policy direction, I guess, if you like, for the US. Clearly, Trump is bringing the US out of the Paris Agreement and the signals his intention to end the Inflation Reduction Act. So there'll be a whole range of grant and funding layer, if you like, of finance, which will no longer be there, at least for the next 4 years. So that's obviously a setback in terms of the US uptake of CCU, and I don't know how many projects will be affected by that per se, but it's also worth noting that a lot of climate policy these days is actually being undertaken at the state level within the US, and even in Republican states such as Texas, just off the top of my head. There are so many winners due to some of the low carbon funding and programs in those states that it's hard to see how all of those or even some of those are going to be rescinded over the next few years. But clearly there's very complex and state level considerations when we look across the US there. Interestingly, I mean, there's a big debate going on at the moment around what the Trump administration means for the COP process itself and whether in fact this may create something of a kind of geopolitical vacuum for China and others to step into. So that really, I think, creates an interesting dynamic, particularly because China has already invested quite heavily in CCS, mainly at the research level. So I think it's a bit of a watch this space, but I would say it's a mixed picture in terms of the current administration.
Thank you very much, Greg. That's all the time we have for questions today. If you have any more questions, please do email Greg and he can get back to you via email. So all I have to say now is the slides from this webinar will be available to download from our webinar page on our website shortly. Thank you very much, Greg, and thank you all for joining us today. Goodbye.
Thanks for your attention. All the best.